Good evening. Comets are fleeting visitors to the night sky and are always on the change, whether it's their magnitude, breaking up in space, or falling into Jupiter's massive atmosphere. Once you have seen your first comet, you will want to see more. I am close to 60 years old now, and I can remember several bright comets that visited our skies. A little before my time was Comet Pearson, which was discovered on November the 8th, 1956, by Belgian astronomers Sylvain Arend and Georges Roland. It was featured on the very first programme of A Sky at Night in April 1957, presented by Sir Patrick Moore. This comet reached magnitude -1. Pearson was visible throughout the year, and by December the comet had faded to magnitude 8, yet it was still visible in small telescopes. I also remember Comet Ikea-Seiki. This was a sun-grazing comet discovered independently by Kuroro Ikea and Tsutomu Seiki on September the 18th, 1965. At perihelion in October of that year, the comet passed within 500,000 kilometres above the Sun's atmosphere, and it was extremely bright at magnitude -10. As it approached perihelion, observers reported that it was clearly visible in the daytime sky next to the Sun. It proved to be one of the brightest comets seen in the last 1,000 years. Comet Ikea-Seiki was seen to break up into 3 pieces just before its perihelion passage. The 3 pieces continued in almost identical orbits, and when the comet reappeared in the morning sky in late October, its very bright tail was extending upward above the horizon. It had faded from view by early 1966. Then, of course, in 1970, we had 2 bright comets on show, Comet West and Comet Bennett. I can only remember seeing Comet Bennett, which was discovered by John Castier Bennett on December the 28th, 1969. It reached perihelion on March the 20th, passing close to the Earth on March the 26th. Its maximum magnitude was 0.0. Comet Bennett was followed by Comet Kohoutek, which was discovered on the 7th of March 1973 by Czech astronomer Lubos Kohoutek. It was at perihelion on the 28th of December when its magnitude peaked at -3. Before its close approach, Kohoutek was hyped by the media as the comet of the century, just like the recent Comet Ison of 2013. However, Kohoutek's display was considered a letdown. Although it failed to brighten to levels expected, it was still a naked eye object. Its greatest magnitude was -3, while at perihelion. Comet Ison was seen by amateur astronomers up until November 2013. However, during its close perihelion passage to the Sun, the comet disintegrated and was never seen again. So there are bright comets that occasionally put on a show, and we are now long overdue for the next comet spectacle. A number of amateurs are outside on clear nights, either searching for new comets or imaging those on view in the night sky. Computerized go-to telescopes of a large aperture are now available for amateur astronomers, which have proven very popular among comet observers. Before 1995, comet watchers were reliant on refractors or Newtonian telescopes on equatorial mountings with setting circles. Comet hunters would get up 3 hours before sunrise and sweep across the eastern sky with their large binoculars or telescopes, searching for a new comet just after their perihelion passage with the Sun, or sweeping the night sky for nebulous objects that showed clear signs of movement during few hours of observation. One such comet hunter was Englishman George Alcock. He died in the year 2000, who lived in Peterborough. He was one of the most successful visual discoverer of novae and comets. In 1953, he decided to start searching for comets. His technique was to memorize the patterns of thousands of stars so that he could visually recognize any intruder. In 1959, he discovered comet C 1959 Q1 Alcock, the first comet discovered in Britain since 1894, and only 5 days later he discovered another, C 1959 Q2 Alcock. He discovered two more in 1963 and 1965. He later discovered his first nova, Nova HR Delphini, in 1967, which turned out to have an unusual light curve. And in 1983, he discovered his fifth and final comet, Iraqi Alcock. Today, the only successful comet hunter to beat this record is Terry Lovejoy, who lives in Queensland, Australia. He has discovered 6 comets, including C2011 Lovejoy, the first cruise sun-grazing comet discovered by ground-based observation in more than 40 years. I am delighted to be invited to take part in the radio program Comet Watch by Nick Everts and Neil Norman, FRAS. Their other guest on the show will be Terry Lovejoy. The program is being recorded in mid-August, so I'm naturally looking forward to it. I have been asked many times, what is a comet and where do they come from? There is quite a difference between a meteor and a comet. If you see a bright star-like object quickly streak across the sky, then it's certainly a meteor. Meteors are small pea-sized bits of rock that enter the Earth's atmosphere from space. When it reaches the denser regions, it rubs against air particles, causing friction. It then becomes luminous, and this is what we see as a shooting star. A comet, on the other hand, is a large chunk of rock mixed with ices. Comets follow narrow elliptical paths, moving in towards the Sun, perhaps crossing the orbits of Uranus, Saturn and Jupiter. As it moves towards the orbit of Mars, the warmth of the Sun gradually melts the ices, forming vapour, which then creates a long dusty tail behind the comet. As it continues to near the Sun, it arrives at perihelion, its closest point. After this, it continues its journey away from the Sun, back to where it came. The dusty glow around the rocky nucleus is called the coma, and there is the comet's tail that always points away from the Sun, so that after a comet has passed the Sun, it actually travels tail first. Then, on occasions, we may see a tail coming out of the front of the nucleus on the opposite side of the grand tail. We call this an ion tail. A gas ion tail forms when ultraviolet sunlight rips one or more electrons from gas atoms in the coma, making them into ions, a process we call ionization. The solar wind then carries these ions straight outward away from the Sun. The resulting tail is straighter and narrower. Both types of tails may extend millions of kilometers into space. As a comet heads away from the Sun, its tail dissipates, its coma disappears, and the matter contained in its nucleus freezes back into rock-like material. Today, amateur astronomers frequently image comets using modern go-to telescopes, and there are several comets on show at any one time, although many are faint and require moderate telescopes of 6 to 16 inches aperture to see them. Brian Jones and myself have been busy editing the new 2018 Yearbook of Astronomy. It contains articles by Neil Norman, FRAS, who informs you about upcoming comets next year. And award-winning photographer Damien Peach shows you how to photograph comets. The new yearbook can be pre-ordered from Amazon. There are long-period comets and short-period comets, which originate from two regions at the far edge of our solar system. Short-period comets include 2P Encke, with a period of 3.3 years, and Halley's Comet, which returns to the inner solar system every 76 years. Generally speaking, short-period comets have orbital periods up to 200 years that have been observed during more than a single perihelion passage. These comets are believed to originate from the region just outside the orbit of the planet Neptune, known as the Kuiper Belt. This region is named after the Dutch astronomer Gerrit Kuiper, who theorized its existence. It was later confirmed by astronomers in 1992. The Kuiper Belt is believed to be a circumstellar disk in the solar system extending from the orbit of Neptune at 4.5 billion kilometers to about 8 billion kilometers from the Sun. In many ways, it is similar to the asteroid belt, except it is much bigger, 20 times as wide and 20 to 200 times as massive. While asteroids are composed of mainly rock and metal, most Kuiper Belt objects are largely composed of frozen ice and rock, ice such as methane, ammonia and water. The Kuiper Belt is home to 3 officially recognized dwarf planets, Pluto, Haumea and Makemake, along with the theorized large planet X, which is still awaiting discovery. When comets from this region travel in towards the Sun, they are disturbed by the powerful gravity of Jupiter, which shortens their orbits, so they become short-period comets. For this reason, they are known as the Jupiter family of comets, which also have a relatively low inclination and in orbit coincided with that of Jupiter's. One characteristic is that the orbit interactions with the planet often trigger the comet's orbit to become perturbed, causing them not to be found at the expected position in the sky, and are therefore lost. So amateur astronomers spend some time searching for these lost comets. Long-period comets are believed to originate much further out in the region called the Oort cloud. The Oort cloud is named after the Dutch astronomer Jan Oort. It is a theoretical cloud of mainly icy bodies that surround the Sun, to as far out as 3.2 light years. It is divided into two regions, a disc-shaped inner Oort cloud and a spherical outer Oort cloud. Comets that originate from the Oort cloud have either parabolic orbits or hyperbolic orbits. Comets in the latter group go on to escape the solar system altogether. We now know that there are a lot more long-period comets than astronomers previously thought, and it seems that the known number has been underestimated by a factor of 7. According to a new study led by University of Maryland professor James Bower, who analysed data gathered by NASA's Wide Field Infrared Survey Explorer, WISE for short. The data includes observations of long-period comets and Jupiter family comets. The long-period comets that WISE spotted were propelled inward towards the Sun by gravitational interactions with other large Oort cloud bodies millions of years ago. The WISE data reveals that over an 8-month period, 3 to 5 times more of these comets passed close to the Sun than scientists had predicted. The study team also found that long-period comets are up to twice as large on average as Jupiter-sized comets. The size discrepancy is likely to be a consequence of the Jupiter family of comets' more frequent trips around the Sun. Every time these icy wanderers get close to our star, the Sun's intense heat drives off water and other ices which drag dust with them as they move through space. The last bright comet to be seen was Hale-Bopp of 1997. It was visible to the naked eye for a record 18 months, twice as long as the previous record breaker, the Great Comet of 1811. Comets are very fickle bodies, so we cannot rely on their predicted magnitude, because chunks may break off, causing the comet to brighten suddenly, or the comet may disintegrate as it nears the Sun. There have been some wonderful comets that have become visible to the unaided eye. Comets have been sighted by the ancient Chinese astrologers about 3,000 years ago, including our friend Halley's Comet, which was first recorded in 240 BC. I say astrologers because the sighting of a bright comet in the sky before the invention of a telescope was interpreted by astrologers as omens of misfortune, heralding pestilence and plague. Wars were fought on the belief that the royal party would be victorious. Of course, on occasions, royal leaders did lose the fight, as did King Harold at the Battle of Hastings in 1066, which was fought while Halley's Comet was on show in the sky. This epic battle was recorded in the famous Borex tapestry. Halley was the first comet to be recognized as periodic until the Renaissance. The philosophical consensus on the nature of comets promoted by Aristotle was that they were disturbances in the Earth's atmosphere. This idea was disproved in 1577 by Tycho Brahe, who used parallax measurements to show that comets must lie beyond the Moon. Many were still unconvinced that comets orbited around the Sun, and assumed instead that they must follow straight paths through the solar system. In 1687, Sir Isaac Newton published his Philosophiae Naturalis Principia Mathematica, in which he outlined the laws of gravity and motion. His work on comets was decidedly incomplete, although he had suspected that 2 comets that had appeared in succession in 1680 and 1681 were the same comet, before and after passing behind the Sun, which was later found to be correct, and the comet was named in his honour. Halley's Comet put on a great show in 1910 as it reached perihelion on the 20th of April, and a great many photographs were taken. The comet has an orbital period of 76 years, and when it headed out away from the Sun, astronomers were waiting anxiously for its next return in 1986. Then, in October 1982, an excited Sir Patrick Moore broke the news every amateur astronomer was waiting for.
Good evening. and welcome to this Sky at Night special. We've really exciting news. Halley's Comet has been sighted for the first time in over 70 years. Of course, it's very faint, below magnitude 24, but that's hardly surprising because at the moment it's over 1,000 million miles away. The discovery was made at Palomar, where there's the 200-inch reflector, and for a long time that was the largest telescope in the world and is still the second largest. It has a tremendous light grasp, particularly when it's used together with a special electronic device known as a CCD, or charge couple device, which is far more sensitive than any photographic plate. Indeed, up to a few years ago, Halley's Comet couldn't have been seen at this distance with the 200-inch or anything else. I can now show exactly where it is. The right ascension is 7 hours 10 minutes, and the declination is north 9 degrees 20 minutes. And if you look at a star map, you'll find that that's in the constellation of Canis Minor, the little dog, quite close to the third magnitude star, Beta Canis Minoris. But of course, at the moment, it is well beyond the range of any except the world's largest telescopes. The discovery was made at Palomar by Doctors Danielson and David Jewett. And I'm delighted to say that David Jewett is now on the line to give us the latest news. Hello, David. Can you hear me?
Yes, I can hear you well.
Well, first of all, many, many congratulations upon having discovered this comet. How long have you been searching?
We've made about 4 searches from Palomar, spread over the last 2 years.
And you were, in fact, using the 200-inch reflector with a CCD?
Yes. We placed the CCD, a charge coupled device, at the prime focus to obtain the maximum sensitivity possible.
Were you surprised to find the comet as early as this?
We really were quite uncertain about the magnitude of the comet. We started searching 2 years ago because we believed the magnitude could have been sufficient for us to see it 2 years ago. So we think it's about time that it's been found. We found it.
Well, 2 very important questions. First of all, you knew more or less the position where it was going to be. How accurate were the predictions?
Well, the measurements are still very preliminary, but we make it that the comet is just 8 arcseconds west of the predicted position. And that corresponds to the comet being 0.4 of a day late in its orbit.
Well, after a total absence of well over 70 years, that is pretty good going. And perhaps even more important, what about the magnitude? I gather that's now between 24 and 25, which makes it one of the faintest objects ever observed.
We think the magnitude is 24.3, plus or minus 0.2.
Now, does that agree with the predicted magnitude, or is the comet too bright or too faint?
Well, the predicted magnitude was very uncertain, and different people predicted different magnitudes. We are in a believable range. It suggests that the cross-section of the comet is on the order of a few square kilometers. It's very small.
What exactly does it look like when you see your results at the moment? A very faint smudge?
It looks like a little tiny star, and the only thing which really distinguishes it from being a star is that it moves in the correct direction at the correct speed.
How many observations
south and west when the stars stay fixed.
How many observations of it have you made up to now?
We have 7 separate frames on which the motion is observed.
So now, in fact,
another frame taken on a different night, which shows that the comet has indeed moved far away from its previous position.
So you do have enough observations now to work out exactly how it's going to move over the next months?
Yes, that's correct. Yes, it's very close to the ephemeris, and we plan to use the ephemeris to plan future observations.
Well, coming down to human feelings, you must have been pretty excited when you first realized that you had got Halley's Comet.
Yep. We were very pleased, extremely pleased.
Well, many congratulations, David. Thank you very much indeed, and thank you for giving us the latest news. Goodbye for now, and many thanks.
Okay, thank you.
Goodbye. So there we are. Halley's Comet has come back into our ken. Of course, at the present moment, as David said, it hasn't got a tail, and it's way out beyond the orbit of Saturn. But it's coming in now, it'll approach the orbit of Jupiter, and it will actually pass perihelion, and that's its closest point to the Sun, in February 1986. And by that time, it will have developed a tail, and remember that comet tails always point more or less away from the Sun. So as the comet comes into the Sun, it moves head first, and after it's passed perihelion and starts moving outwards again, it travels tail first.
The comet will next return in 2064. Then, of course, there was the tremendous excitement surrounding Comet Shoemaker-Levy 9, which broke up and all of the pieces slammed into Jupiter.
Shoemaker-Levy 9 is a comet that was discovered by David Levy, Carolyn Shoemaker, and Gene Shoemaker. We had about 9 months of warning that this comet was going to hit Jupiter. I knew from the calculations we had done beforehand that if Hubble was working at the peak of its game, that we would get images that far surpassed images that could be taken with any other telescope on the Earth.
Proper shot, she's going in. Camera 3. She's bursting in, go high.
That it probably indicates we're dealing with larger objects than was concluded by Ashfog and Benz. And I think we may have some up-to-date information from IDM.
Gene Shoemaker said he would be personally astonished if we saw nothing. Well, he's not going to be astonished. We actually saw some amazing things.
The comet delivered. I mean, it delivered big time. It had big black spots, and if you looked at certain colors of light, it had white spots, and it had the rings, and it had plumes, and it had big giant storms. And I was really proud to be a part of that, and I was really proud that all the engineers and scientists could pull together and make that happen.
Comets are fascinating to observe and photograph. If you would like to learn more about observing them, do join Neil Norman's Facebook group, Comet Watch, where you will see images taken by more experienced comet observers and learn a great deal about how to observe them. That is all we have time for this month. Thank you for watching. If you like this program, please share it with your friends and members of your local astronomical society. Until we come back next month, good evening.